Automotive assembly workers frequently lift and position heavy automotive components. The automotive companies provide them with lift assists, also known as material handling devices, on their workstations. It reduces the gravitational weight of those objects. But the workers are still managing the inertia of the entire system. By system, I mean the weight that they're lifting, like the object that they're lifting, and the moving parts of the lift assists. We basically want to see how different lift assist designs, how different task conditions affect the physical demands of workers and their user perception. We can very precisely measure their motions. We can also measure the activity of their muscles. We can very precisely measure the hand forces that are required to maneuver these objects. We're trying to simulate the task conditions as to how they are in the real automotive assembly plants. By different conditions, I mean across three conditions of the lift assist. One, where we have this jib crane lift assist. Second, where we have this gantry lift assist. And the third, where they're doing it manually, like the control condition. Our overall goal is to develop some practical and evidence-based guidelines for operators to better use it, for ergonomists to better implement it, and for the manufacturers to better design and manufacture it, which will ultimately lead to a safer work environment for the automotive assembly workers.